Classification of VMS deposits. VMS deposits have been classified on the basis of host rocks, metal contact, and alteration assemblages. All three ways of classifying them pretty much agree. For our purpose, we will use a classification scheme based on host rocks, with each class named for a VMS deposit or camp in that class. This is done because it is easier to associate host rocks, metals, etc. with a place name than with a generic name like bimodal mapping. In a host rock classification scheme, there are five major deposit types. Number one, Noranda type. This type is named for deposits found in the Noranda area of Quebec. In this deposit type, mafic lava flows dominantly basalt, or the dominant volcanic deposits typed throughout the stratigraphy, but the VMS deposits are hosted by felsic, rhyolite, dacite lava flows and are domes. These are copper zinc deposits and are also referred to as the bimodal mafic class. Matabi type. This type is named for VMS deposits in the Sturgeon Lake area of northwestern Ontario and for the largest deposit found in the camp. Felsic volcanic rocks, dominantly rhyolites, comprises most of the volcanic stratigraphy and the ore is hosted by volcaniclastic rocks. These are zinc copper lead deposits and are also called siliciclastic felsic. The Matabi type can be subdivided into two subtypes which are similar to epithermal gold deposits, low and high sulfidation deposits. Number 3. Bathurst-Rio Tinto type. This deposit type is named for the large VMS deposits in the Bathurst camp in New Brunswick and also for the giant Rio Tinto deposit in Spain. The volcanic stratigraphy is similar to Matabi type deposits, but they also contain a lot more volcanically derived sedimentary rocks, including iron formations. The ore is hosted by either felsic volcaniclastic rock or felsic lava flows and domes. These are zinc copper lead deposits, which are also referred to as siliciclastic felsic sedimentary. Kid Creek type. These deposits are named for the Kidd Creek mine in Timmins, Ontario, and the numerous VMS deposits found in the Green Tuff region of Japan. The ore deposits are hosted by felsic lavas and domes, as well as block and ash flows and dome breccias. In the case of the Kidd Creek deposit, ultramafic lavas occur in the footwall stratigraphy. These are zinc, lead, copper, silver deposits and are also called bimodal felsic. They, like the Matabi type, may be subdivided into two subtypes, low and high sulfidation. Cyprus type. This kind of VMS deposit is associated with ophiolites assemblages and is similar to what is forming today on the seafloor at divergent zones. The VMS mineralization is hosted by basalts. They vary from paleolavas and clastites to sheet flows. Mafic diets are ubiquitous and there may be small cryptodomes composed of plagiogranites. These are copper zinc deposits. All of the volcanic host rocks formed subaqueously, which is a necessary condition for the formation of VMS deposits. Location of a VMS deposit within a volcanic stratigraphic sequence appears to be related to a change in either magma Composition or eruptive style, that is basalt to andesite, pyroclastic flows to lava domes. The felsic volcanic rocks tend to be high in silica and have low zircon yttrium ratios, less than 12. Overall, they are high in Zr greater than 300 ppm and Y greater than 30 ppm. La-Lb ratios are low, less than 6, and the rhyolites have elevated LREEs and HREEs, which are typical of high temperature magmas. Deposit types, volcanic rocks, and ore grades. Number 1. Cyprus type. The volcanic stratigraphy is dominated by mafic lava flows, basalts with abundant pelolavas, haloclastites, and sheet flows. Sheeted base dikes are everywhere, and marine sediments, including chert, manganese-rich, are common. This stratigraphy is classic of a light sequence, though the VMS deposits seem to occur where there is a change from basalt to andesitic volcanism. Plagiogranitic intrusions may occur near the top of the stratigraphic section. There are no felsic volcanic rocks. The sulfide minerals in these deposits are pyrite, chalcopyrite, sphalerite, and marcasite. Cyprus-type VMS deposits are typically small, less than 2 million tons. Examples include deposits in Oman, Cyprus, and on the modern seafloor along divergent zones, black smokers. Number 2. Noranda type. The volcanic stratigraphy is greater than 80% mafic volcanic, basalt, and andesite, and these lavas vary from pillowed flows and hyaloclastite to sheet and massive flows. Rare cinder cone and tuff-ring deposits, hyalotopes, are present and mark a distinct shallowing up of the sequence. Though the stratigraphy is dominated by mafic volcanics, there is up to 20% felsic lavas found throughout the succession, and these vary from lobe haloclastite complexes and cryptodomes to blocky domes and dome breccias. These felsic rocks, rhyolites and andesites, are of great importance because they host the VMS deposits. They thus represent a dramatic change in magma type and style of volcanism. Or all the deposits are small though gecko and flin flon are exceptions. Grades average 3.5% coppers, 5% zinc, 1.1 oz per ton silver, and 0.02 gram per ton gold. There is no lead. Examples include Noranda, Flin Flon, Winston Lake, Gecko, and in Minnesota, the 5 Mile Lake occurrence. Number 3, Bathurst-Rio Tinto type. These VMS deposits are similar to Matabi in that they have abundant felsic fragmental rocks in the stratigraphy, but they differ by the presence of volcanically derived sedimentary rocks including wax, siltstones, iron formation, and argillites. These sedimentary rocks represent either caldera fill in the hanging wall or basin fill in the foot wall. Like Matabi, sediments also occur intermixed with the felsic volcanic and represent material derived from basin or caldera walls. Fragmental felsic rocks, pyroclastic flows, or debris flows may host the ore, but so do domes and lavas that mark the end of the felsic volcanic succession. Similar to Matabi in grade, they tend to be much larger deposits. Number 4, Croco kid type. In these kinds of VMS deposits, The hanging wall and footwall rocks are dominantly felsic, greater than 70%, but they differ from the previous two types in that the felsic volcanic rocks are domes and lava flows with associated block and ash flows. Volcanic sedimentary rocks occur throughout the succession and in places. Kidd Creek ultramafic lava flows occur in the footwall. These deposits vary from small, less than 1 million tons, to giant, greater than 100 million tons, with grades that average 1.5% copper, 1% lead, variable zinc 3 to 7%, 3.5 Oz per ton silver, 12% barium for non-Archean deposits. Examples include the Kuroko deposits in Japan, Kidd Creek, and a Myocene knoll.